Hello everyone, I'm back. So this definitely is not working. Actually, I don't even want to debug this thing. I mean, I tried it. We got it working with the example, and then we got stuck here. I tried to work it out, but I don't feel like it. Yeah, it's one of those things. And that put in a nightmare. Yeah, it's tough, very tough. So after a year, I think the last time we do this is March. After more than a year, still no improvement. So, okay, we know it's working backwards, but Q, wait, hold on. This looks really similar to what I'm doing right now. When I'm using a Q, I don't know. Anyway, so I decide to not go forward and let's see the solution. It's late, I just finish it up. Call it a day. Yeah, we know we have to go back to the front. Exactly, that's my idea. Reverse step. That's exactly what I was trying to do. Huh? Maybe we should. You know what? Let's just read. We don't have to see the implementation. I just try to see how similar it is from my idea. Currently, it's very similar. Okay. Yeah, we know one. That's exactly what we're trying to do. We reverse this, and then we have the suffix and prefix. How many cells initially match? Yes. Which ones don't? Have no to-do list get enqueued. We'll enqueue the positions of each character. I don't understand anything, but this kind of tell me what I have might actually work, but I need to do it slightly differently. I just have an idea. Every time we set, right? How about I just put the ones that's not into something, into a queue, right? So all the part that's not currently matched, I put inside. Not matched, I put inside. And then we pull it out. And that one, we can try to match either from the front or from the back, because it's required either from the front or from the back, right? If it's on the left, there has to be a suffix. If it's on the right side, there has to be a prefix. Then we're using exactly the same method here, but it's slightly different. You see what I'm saying here, right? Did you see? Then we don't need this, okay? We don't need this. We do need a queue, we need a result, and we have this. This is all fine. But instead of putting in this, whenever we find this, we put in, right? If I is not 0, we're going to put in, but not putting this. So we say I to I plus m is the step. So what we're going to do is the poof, this put in, right? And then I see what you're saying. I see what you're saying. We need a start. We need a left. We need a left equals this, right? And then we say if this is equal to stem, and okay, then we have this in the middle, something. Then we have on the left side, so we say else string shall equal to target from left to I. Okay. Then we say if lstr. What the hell? What are you doing, man? lstr, then q dot append lstr. So whatever that's not matched, we put it in the queue, right? And then don't handle this side. We don't have to do any of this. And the rest of append because that's that, right? And then I plus equal to m. Perfect. Otherwise, I will do one at a time. But when we do this, left has to change as well. So left now equals I plus m. Well, technically speaking, because I did plus equal to m and left equal to I. Right? So we completely move to the new starts. And then we do the same, right? Otherwise, if it don't match, I just go forward. So once we do all this, if not rest, then we don't have to keep going. We just say return this, which is perfect. And then we have the sets. We have the prefix, we have the suffix, right? So we get both. Once we get both, we can go into the queue. In the queue, everything we have to match. So for each of them, we can match the front and match the back, right? Yeah, we match the front and we match the back. So front, we match however much we can say we want to do as much as we can. Don't want to do just a small part. Because if we just do a small part, we can always do a bigger part. So we try to do as much as we can. Alright? So now we can just say for target for s in q, right? So for each s on the left, we want to match the reverse. No, on the left, we want to match the suffix. But what if it's at the front? We should note, because if it's the front, we should always match the suffix. We should never match the prefix. So maybe is a left string. Oh, when you're missing the right string. So when we get out, should be Q, should also append target left to the end. Actually, okay. Q, if not S, continue. Okay. If S, so we need to know if we can go both sides or we need to go a single side. So just say target, and if it's one side or both sides, so it can be, okay, say B is both. Either left or right. Right, left, right, so L, R, B. And then we say this one, if left is 0, then we can say we just do right. Else, do both. And this one, we always, because this is the last one, right? So we always need to do left. We don't need to do right. Okay. And then we say the S and option, right? And we say if option is equal to R, so we do right, or option is equal to both, then we do on the right side, right? But how do we do on the right side? Well, we do on the right side by, so we have that, the original string, but now it's just a piece of string. And then we want to do on the right side, which is actually the prefix, right? Then we have this S, then we can go from the last one, just going front, right? And then we go as much as we can, and just to see if this one is inside, right? And we want the longest, basically, right? The longest. So we can say max L, max length, I can say equal to 0. Then for I in range from len S minus 1, right, to 0, we say if S from I to the n, right, is in prefix set, max len shall equal to, because we go, the max length are getting bigger and bigger. What's the max length? Actually, do we even want max length? We just need a prefix, right? We just need the index. We just say left, right? So left shall equal I, right? Because so I is from this, And then if it's too big, right? If it's too big, then we say if the length so the len is minus I, right? If len s minus I, that's the whole length, become larger than m is the length of the stamp, then we're going to break it out. Otherwise, we're just going to do this, right? Blah, 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 blah. As we go through the whole thing, right? Once we go through the whole thing, we'll have a left value. Okay. We have a left value. What if we don't have a left value? We just go through the whole thing. Nothing fits in the prefix set. Then we say if left is smaller than 0, that's our return empty. Otherwise, then we have a left. Okay. Actually, left shall equal to len s minus 1. That's just the end. And I'll go got to the left. Else, I should rest.append left, because that is where we need to put the stamp, right? So that's this. And then we say if OPT is equal to left, or OPT equals both, right? If that is the case, then what? So now we're on the left side. Then we want a suffix, right? Then we have a right, which means when I say right is equal to 0, we start. Then we say for I in range, to len s. Then we say if that's actually going to be I plus 1 is larger than m, and break. Otherwise, we say if s, suffix all the way to I plus 1, right, is in suffix set, then right equals I, which means we can extend to here, right? And then we blah blah blah. Once we're done, once we're done, okay. So if right is smaller than 0, then return this, which means we cannot find an I that fits the suffix. Then we search the entire thing. nothing fits. Else dot append. So we'll have a right where we say we fit the suffix. So from this to right, this fits. Right? Then what is the I might have an issue here. Hold on, let me think. No, it should be fine. Yeah, we should be fine. So we say we have a right. So from this to this right. What's the left? What's the index? So we should have the index. So basically right minus this index plus 1 shall equal to m. So it's going to be right plus 1 minus m. Right plus 1 minus m. That's going to be that. So when we get out, we have a left and right. We have a right is here, left is here. So the temp need to append. We can say if right is smaller or equal to left, then we're going to append target. Actually, right plus 1 smaller or equal to left minus 1, right? Has to be this way. That means we have more. Then we'll say we'll do target right plus 1 all the way to left. Yeah. Otherwise, we don't even consider it. So we do this, and we get a new one. And for each one, we do this. Okay, so what if for the ones we only do right? Okay, we only do right. So we get the left. Okay, and then right, we'll say minus 1. Then we say minus 1 plus 1, which is 0. Then we'll do target. Okay, from right plus 1, that'll be 0 towards the left. We're going to do the same OPT. So if its original is a right, we'll continue to do right. For original is both, we continue to do both. Okay. So once we're done, we can say Q is equal to temp. Go back. Try it again. So every time we get smaller and smaller strings. And for each string, we try to fit the prefix and suffixes, right? And if we go both ways, and they cannot do, then we just don't put it inside. And then once we're done, we are going to return the rest, reverse style. Okay. If it works, name target is not defined. Where? Don't even print this. Oh, looks promising. Minus 2. Okay, we have a little bit issue with this one. Minus 2? What? What are you talking about? Minus 2? Somebody got -2. -2, supposed to be 3. Hold up, let's print the Q. Let's take a look what happened. So, first one we got is A and R. We do A, R. Oh yeah, the right and left, A, B, C, A, right? So we say A we must do right, C, A we must do left. That's correct. And for A must do right, which is right, then we say I, because that's just A, right? So we do 0. That's just 0. That's fine. Is in prefix? Yes. So left equal to 0. That's it. Left equal to minus? No. And then parallel left. Perfect. Right is -1. If this equal to left? No. So we did this. And now, so we don't do this block. And then we say right is -1, so it's 0. Left is 0. That's -1. And this is 0 smaller than -1? No, so we don't put into it. Perfect, that's good. Okay, so we go back up. So CA comes out. CA comes out. Left, guys, L. Don't do this, so we do this. Right is -1. And for I, range, so we're going to start from 0 here. No. So to 1, so we say C. Is C in the suffix? What's the suffix? C is not in the suffix. I'll just print it out, suffix and prefix. Okay. So we're going to do the left, which is suffix. C is not in the suffix. So no. Go back up. Next one is CA. CA is in the suffix. So right equals 1. Right equals 1. So 1 plus 1 minus 4, I guess. Right. 1 plus 1 minus 4. That's where -2 comes from. I see. So what we have to find is, it is -2 in terms of that thing. But in the grand scheme of things, Jesus, we need to push another thing, unfortunately. Left and right. Instead of doing this, I just push left and right. Okay. So we have a left. What is the right? I minus 1. That's the right. What's the left? Still going to be the left. What's the right? N -1. Okay. So when we do this, it's not going to be an option. we can just call it L and R, right? We say if we only do the right side, so if so one is a 0 something, and it's something to n-1, and everybody else. So first situation we'll do right only. So right only. So if L is equal to 0, should be if R is not equal to, yes, let's say if R is not equal to n-1. So if we're not on the, so yeah, so say do right side of S, which is prefix matching. Then we'll do blah 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 blah. Then we're gonna append what? Append, no, this one is right. That's fine. And then this one is say if left is not equal to 0, right? And then we say this is do left side of S, which is suffix matching. The left side, which is suffix matching, yes. And blah blah blah, which is fine. Then we say we're gonna append. Now this is something we need to work with. So we have this, then we need to append. What do we append? I mean append right plus 1, right, that's just no, it's going to be the actual. The left and right is not the actual thing. We need to do the actual thing. So left and right are the indices in the current string. But in the current string we do have the L and R, right? So I have to first figure out this is not left. Prefix, right? So I come out is, hold on. We have a string, right? Now we match to the left. So these all match. So I want to know what is this left index in the grand scheme of things. And we know this one, right? We know this is L. So what we can do is minus L plus 1 shall equal to left plus 1. So this shall be L plus left. So this I'll call it L plus left, right? And then on the right, so we start from here, right? And now we go, and eventually we do suffix matching. So we do into here. Okay, so this is right. That's fine. And then we say when to find its actual. So we again we know this is left, right? Then what do we do is we say we have something, and so we say it's going to be the right. We have this, I know this. So I know it's L plus right. Right, so L plus right is this. So this minus unknown plus 1 need to equal to M. So it should be L plus right plus 1 minus M. So that's what we need to assign here is L plus right plus 1 minus M. That's index of the left. We're not doing anything with the right. I just realized. But we need a right to do this. Okay, so what is this? In the grand scheme of things, L plus right and L plus left. That's in the grand scheme of things. So we do this, then we pass. Okay. Come out this. Oh, this one looks promising now. Try this. Wrong answer. Okay. Again. Yeah, I shouldn't delete them. Okay, and then we just print Q and take a look. So we have OZ, right? So it should be Z and OO. OO 0, 1. Z is 0, 1, 2, 3, 4, and 4. And then for OO, actually we need to say, let's do the rest as well. Let's see what we put in. This is 2. And then we put 1 and 3. Because on OO, we can do OZ. So we do 1. Now we have O left. think it should be +1. Shouldn't it be -1? Yeah, it should be -1 because the target, and we want a target index. Okay, so now let's do all these. This is a small issue. Doesn't affect. Okay. Nope. Two, 1, 0. All right. Let's take a look. CAB. Okay. This one's fine. This one will get eliminated because I said if not, I'm going to continue. So basically, we're handling BB, right? BB, we can do this and this. 0. On the left, 1 and 2. Yeah. Hey, that is not right. So I have BB now. BB 3 and 4. So we don't do right. We're going to do left, okay? So we focus on this. So right is -1. There's 2 to 0 and 1. 0 plus 1 is 1. No. So that's B in suffix. Yes, B is in suffix. So right equals 0. Okay? So right now is 0. And try it again. Now BB is not in it. Then we go out. Right is 0. So rest of append zero. Yes, we have 0. Hey, hold on. Not 0. It's L is 0. Plus right is 0. Plus 1. Now L is 3. 3 plus 0 plus 1, 4. 4 minus 3 is 1. So that's why we have a 1, which is understandable. And then right is 0. That's 2. Left is equal to -. Minus is 2. 2 minus 1. So 1 smaller equal to 1. Yes, this is still correct. And the thing we push in is just wrong. I see. Has to be L. Has to be L. There we go. Okay. Yep. All right. All good. Try yes one more time. We are going to solve this problem using our way. Oh my god. This is no good. What's the problem now? Can't believe we still have a problem. So I get this, 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 and this. Then we just do this and this. Now we're done. Right? We get 1, 3, 6, 8. One, 3, 6, 8. Then we just need to do 0. And 0, 1, 2, 3, 4. I think there's 0 and 4. Yeah. I got 0, 0, and y. Why did it come out as this one? 0 and 0. So we do the right. Yes. Right? Minus is 1. So 0 plus 1 is 1. And then that's b. Is b in the suffix. B is not in the suffix. Wait, hold on. Why should we do the prefix? Yeah, right, should we do the prefix? Yeah, here. My bad. L is 0. What is this? Prefix. Prefix. 0. I is 0. Yes. In the prefix. Yes, it's in the prefix. So left shall equal to 0. I shall expect to see a 0. What happened? Left is 0. Oh, I think left is 0. So this left 0 is right. And now y comes in. Can do both sides. Oh. which means if one of them has done them entirely. Which means if one side didn't do anything, right? If the other side also didn't do anything, we should say if as long as one side did something, then we shall be able to push for the next one. So what I'm going to do is if the left change, right? If left is not equal to this, then I just append. If right is larger equal to 0, then I can do this. And then we say, right, and the original, because if neither has changed, right, we say if right plus 1, and then left minus this. If this is equal to -s, which means nothing, no match on either side, then we return. Otherwise, if this, then we continue. Oh, we did have 0 and 4, so we can try this one. In my opinion, this one should be correct. We can try this. Try the other one. Okay. So this is the last one. Let's put a test case. And comment out. Run it. Yep. Which means this is correct. So this is correct. Yeah. All right. Try this. Still want to keep going? There's no end. Seriously, there's no end to this. Pretty sure you will not get this one, so let me just get this one first. Like, what else have I not considered? Thought I considered everything. Okay. So we get to B and S. We got 2, 7, 12, 15, 0, 4, 8, 16. Well, it doesn't matter the order actually. So we get down to B. And S. Oh, S we can keep going. This is a single S, which is fine, honestly. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That's fine. This S is fine. The B, 0, 1, 2, 3, 4, 5, 6, 7, this one. Oh, hold on. It's neither a prefix nor a suffix, but madre mia, it's in the middle. Let me think. This is changing a lot of the things. Basically, what we're asking is if we have a string, right? If the string is longer than the stamp, then if we want to remove it, then we have the only way is prefix and suffix. That's correct. Right, if the string is smaller than the stamp, then as long as it's inside, then we are good to go. Yeah, if you think about it, if the string is smaller than the stamp, then all we need to do is, as long as the string can be fit inside the stamp, it could be suffix, it could be prefix, or it could be somewhere inside the string, which means we shall say if Linus is smaller than if it's smaller than, right? And if we do a prefix, yeah, it should be like if it's smaller than m and s in m. Can we do that? It's actually a good question, I don't know. Can we do that? Is, say, BC in A? It's BD in A? Oh, wow, I think I can do that. So say if S is in M, maybe we can just call index. Oh, substring not found. S is in it. Then we just put a stamp like that. Then what do? S is in it. Can we do BC? And we return the index of this. Okay, then we have the index. S inside M. We get the index inside M. But does that help? And I know what this is. Yes, it does help. How? Well, we get it's actually going to be stamp.index, right? S is the index, and then so this is a stamp. I know this index. I know it's the overall index, right? I know it's overall index. Then I need to know this thing's index. Well, this thing's index is 0, right? So this thing's, so we have this minus this thing's index shall equal to the index we just get it minus 0, which is just this. So it should be L minus index. So we say L minus this shall be put into res dot append and continue, because we take the entire thing. Then we should just continue. For this, int is not iterable. Huh? Oh, not the stem. Alright, so this one we need to check. So basically I think we just add this piece. Oh, is good. Try one more time. We'll keep trying. Like, honestly, we'll keep trying. Until we get it right. So we have F, 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 E, F, F, E, B, B, B. So what I do is I do 0. I think I remember these things. Do 0 and with 6. 3, 4, 5, 6. F, E, B, B. Okay. Target is F, 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 E, F, F, E, B, B. Oh, I think we got too long. What? Hold on. F, 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 E, F, F, E, B, B, B. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so it is 0, which is F, F, B, B. 0, 1, 2, 3, 4, 5, 6. F, F, E, B. How is that possible? I'm not supposed to do this. Now that I kind of remember this whole thing, FFEBB stuff, struggled a lot last time. Well, so the first one is 4, FFEBB, FFEBB, so 0, 1, 2, 3, 4, FFEBB. And then we want to do this B. Oh, I only picked the first one. Crap. Oof. We have to avoid it getting out of reach. Right, B is 9, 9. That's what we're looking at right now. B is 9, 9. So if it's 9, 9, we have multiple options. can we get all the indices that it occurs? Maybe there is one. I don't know, maybe. Is there a function to do this? Rejects. Find. What does find do? Does find do the same thing as index? Probably do the same thing. And then what? Get a substring? Ooh, we can have a start and end. So basically, we need to write a separate function here. Right? So we have to check if it's valid. Okay, so it's in stamp. Then what we do, we're gonna find the first one. Oh, what if it doesn't exist? Oh, we'll probably return -1. Yes. True. Oh, I can call index equal to stamp dot find s. Right. If index is equal to -1, down a break. And now we have a L quite left. It's fine. It's in break, right? Otherwise, we find an index, and then we say if L minus index is larger or equal to 0, and L plus index, right? Because L is here, index is here. Actually, no. Hold on. We have this, and we have this is index, this is L, right? Say index is this. That's no, L is here. L minus index, yes. How about this one? Well, this is index. This one, when it say this is m minus 1 minus index, so equal to the one we want to find, minus L. So it's m minus 1 minus index plus L. So this should be m minus 1. But remember, we have R. Okay? We have an R. Which means... Oh, what do we want? We have R. We have here we have L and R, and then this is giving me the index, right? And we can compute the front is L minus index. Fine. I want to compute also the end, and then we say it's the end should be n minus 1 minus index should equal to, we don't know what this one is, minus L. So this should be n minus 1 minus index plus L. So that's the overall right. So, and this one should be smaller than n. Then we're gonna do L minus index and break. If not, right? If not, just say left equal this, index equal to 0, right? So index. Yeah, this is the one. Yeah, if this one, find the first one from here, find here, if it doesn't work, then plus 1, then minus 1. So I start from 0, find the first index, right? If this one works, that's perfect. If when this one doesn't work, either left doesn't work or right doesn't work, then I will come back, try to search, just do one later. Did that work? I'll do one later. So I say from this to this, the first occurrences, right? And then we want to find from, hold on. FFEBB, right? It of find B 0, 2, 3. 4 is 4. Start from 4, 0, 1, 0, 1, 2, 3, 4. So yeah, plus 1. On the next possibility, if we find, edit. If we cannot find the entirety, just fine. Okay, so what's this? I have 0514. What's the original I have? Let's see this. No, actually, we have to check. Say if index is larger equal to 0, it's not -1, which means we don't break out from here. Then we will continue. Yeah, this whole thing just gets more and more and more convoluted. So for, no, not the entire thing, just this thing. If s try this. What is this? Oh, my network is fine. Is their thing is bad, but 0514 works. Zero. Let me see. FFEBB 5 0 1 2 3 4 5 FFEBB 0 5 1 0 1 FFEBB and then 4. Okay. Try it again. Oh, yes. Oh, yes. Oh, yes. Holy crap. Holy crap. That was the fastest. 50 milliseconds. That was totally worth it. Man, oh man. I gotta write an article for this thing. Damn. Holy crap. I even have the print. Oh, I don't have the print here. Holy crap. How? Alright, I think I'm gonna end here. I have a lot of questions to deal with, but I don't want to deal with it anymore. It's too late. Alright, so anyway, we got 100%. This is unexpected, but after the struggle, we struggled yesterday, we struggled today. Damn. Anyway, this is a good result. But I'm gonna investigate more. Maybe now, maybe tomorrow. But anyway, I'll see you guys tomorrow. Adios.